Right, good afternoon, grade 10s. Yesterday we did questions where we were simplifying complex exponential expressions, where we had multiplication and division. Today we are going to do similar expressions, so complex exponential expressions, but with addition and subtraction. Now, what I want us to do, I'm quickly going to go back to our very first note that we made on exponents and the laws of exponents specifically. And if we just look through these six, yes, there were six. If we just look through these six laws that we wrote down, I want us to recognize that there are no laws for adding and subtracting, right? There is no law that tells us what to do if we have something like this. There is no such thing. There isn't actually a one-size-fits-all rule or law that you can apply in a situation like this. So where you are adding or subtracting, if you have exponents with different bases, if you have powers with different exponents, or if you possibly have the same exponents with different bases, right? There are no laws of exponents in these six that work specifically with addition and subtraction. So when we now have complex exponential expressions with addition and subtraction, we need to do something completely different. So we're going to go straight into some examples so that I can show you guys how we are going to treat these questions, and also just so that you can see what these questions could look like. All right, so the instruction is to simplify the following. Okay, and we are going to start with a very simple one. This is a fraction. I'm just writing it over two lines. So we're starting with 3 to the power of x plus, 2 times 3 to the power of x. And that is all over 3 times 3 to the x minus 3 to the x. All right, now what I want you guys to notice first is that at the top of this fraction, we have two terms. At the bottom of this fraction, we also have two terms. And we remember from when we did algebraic fractions earlier on, that means that we cannot cancel out. I know it's tempting. I know that it looks like lovely. There's a 3x there and a 3x there. Let's just cancel them out. But we are not allowed to do that, guys. Not if you have more than one term. So what do? How do we go from more than one term to only one term? We factorize. All right, so that is going to be your go-to method or strategy, I should rather say, in these types of questions. Whenever you are working with addition or subtraction, or addition and subtraction, because pluses and minuses separate terms, whenever you're working with addition and subtraction, you are going to have more than one term. So that is why you will always actually have to factorize with these types of questions first. Okay, so I'm hoping that we can notice that at the top, we have a 3 to the power of x in both of those terms. So I'm going to take that out as a common factor. So I'm going to say 3 to the power of x is my common factor. Remember, when we're taking out a common factor, we divide. So I'm going to say 3 to the x divided by 3 to the x is 1. And then from the second term, if I take away that 3 to the x, I'm going to be left with plus 2. Now, if I look at what I have in my numerator, I have one term, which is what we want, because then we could cancel out. At the bottom of this fraction, we also have a 3 to the x in both of these terms. So I'm also going to take 3 to the x out as a common factor in my denominator. Now I'm going to divide each of those terms by that common factor. So if I take away the 3 to the x from the first term, I'm left with 3. And from the second term, negative 3 to the x divided by 3 to the x is negative 1. Here, I now also only have one term, which means that I am now allowed to cancel out. Okay, and that is what we're going to have to remember with these addition and subtraction questions. First factorize and then cancel. So now we can cancel out the 3 to the x and the 3 to the x. At the top of my fraction, I'm left with 1 plus 2, which is 3. And at the bottom of my fraction, I'm left with 3 minus 1, which is 2. So the final answer here is going to be 3 over 2. Right, we're going to now do an example that is slightly more complicated in the sense that you can't just factorize straight away. So I'm looking at something like this. In my numerator, I'm going to have 7 times 2 to the power of x minus 3 times 2 to the power of x plus 1. And that is then going to be over 2 to the x minus 2 to the power of x minus 1. Now again, guys, we have two terms at the top and we have two terms at the bottom. Even if you had two terms at the top and only one term at the bottom, you still wouldn't be allowed to cancel out. Whenever you have more than one term, either at the top or the bottom or both, then you cannot cancel. All right, so again here, we need to remind ourselves, how do we go from multiple terms, more than one term, to only one term? We factorize. Now guys, in the previous example, it was very easy to see what we had to factorize. The 3 to the x, I think it was clear as day that that was the common factor. In this example, we now have two terms in this, well, one in the numerator, a term in the numerator, and I should actually rather highlight that, and a term in the denominator where my exponent also has multiple terms. So here I'm going to just make a little arrow. I'm going to write exponent has multiple terms. And it's actually the case for that one as well. Now guys, what we're going to do in this example, and whenever your exponent has multiple terms, we are actually going to split the exponent up, because can we see that not the entire exponent is common in both of these? We have a 2 to the x plus 1 and we have a 2 to the x minus 1. Here we have a 2 to the x and a 2 to the x. So 2 to the x plus 1 can't be a common factor. 2 to the x minus 1 can't be a common factor. Those four expressions that have a base of 2, those 2 to the power of somethings, those four are not the same. We need to create something that's the same. So for example, in my numerator, I'm going to want to take out 2 to the x as a common factor. But here I have 2 to the x plus 1. Which means that if I want a 2 to the x on its own that I can take out as a common factor, I'm going to have to split that second exponent up, the x plus 1. I'm going to have to split that up. All right, so let's write that down and then I'll show you guys how to do that. So therefore, split exponent up. Now guys, we know this exponent law, right? We know that if we have a to the power of m times a to the power of n, that will give us a to the power of m plus n. So for example, if we have 2 to the power of x times 2 to the power of 1, that will give us, because we have the same bases, 2 to the power of x plus 1. So we're used to applying this exponent law in this way, where we have two separate bases and we are putting the two exponents together so that it forms one exponent of one base. Now we are going to move in the opposite direction. We are now going to start with a single base of 2, multiple terms in the exponent, which we are then going to split up into two separate bases of 2. The one exponent is going to be x, and the other base of 2 is going to have an exponent of 1. All right, so from there, let's do that. We're going to say we have 7 times 2 to the power of x. I don't have to split up this first exponent because it only has one term in the exponent. I'm only going to split up exponents that have more than one term. So here I have a 3 times 2 to the x times 2 to the 1. So that exponent of x plus 1, I'm going to split up into two separate bases of 2, and the one base is going to have an exponent of x, the other base is going to have an exponent of 1. We are now going to do the same thing in the denominator. The first term is fine, 2 to the x. Now the second one, the second base of 2, I'm going to split that exponent up. So I'm going to say 2 to the power of x times. Now I know that usually when we have a subtraction, we think that we're dividing. But it's also the same, guys, as if when you do this kind of thing. 2 to the x times 2 to the negative 1. If we just do that on the side, 2 to the x times 2 to the negative 1. If you apply our multiplication rule, you would say x plus that second exponent, which is negative 1. And that will, in fact, give you an exponent of 2 to the power, well, an answer rather, of 2 to the power of x minus 1. All right, again, we are going in the opposite direction. We are starting with 2 to the x minus 1, and we are splitting it up into two separate bases of 2 with two separate exponents. All right, now from here, I'm sure you guys can notice that we have a 2 to the x that's common at the top. So we're going to take that 2 to the x out as a common factor, and we're going to write in those brackets whatever is left when we divide by that 2 to the x. So it's going to be 7 from the first term, and from the second term, we're going to have a minus 3 times 2. So you can write it as 6 straight away if you feel comfortable with doing that. There's no problem with that. At the bottom, we are again going to take out 2 to the x as a common factor. So we're going to write that 2 to the x at the bottom in our brackets. We're going to divide each term by 2 to the x now. So what is 2 to the x divided by 2 to the x? It's 1 minus, now we're going to be left with 2 to the negative 1, which you can write as a half straight away if you feel comfortable with doing that. So now we're going to cancel out the 2 to the x and the 2 to the x, because we now have one term at the top and one term at the bottom. So we're going to be left with 7 minus 6 at the top, and we're going to be left with 1 minus a half at the bottom. And you are welcome to type this into your calculator if you want to, or you can just work it out in your head. It's quite an easy one to do. 7 minus 6 is 1, and 1 minus a half is a half. So 1 divided by a half is 2. All right, now I'm going to do another example, which is a little bit more complicated in the sense that the common factor perhaps isn't as obvious right from the start as it was in the previous two examples. So we have something like this: 3 times 10 to the power of 4y minus 6 times 10 to the power of 3y, and that is then all over 3 times 10 to the power of 3y. So when you get to this question, you will see, okay, I have two terms at the top. I do have only one term at the bottom, which is good, but since I have two terms at the top, that means that I cannot just cancel out. I'm going to have to factorize in order to create one term at the top, and then I have my one term at the bottom, and then I will be able to cancel out. But as it stands at the moment, it doesn't look like we actually have a common factor at the top. Now guys, what we're going to have to do in this case, and some of you might be able to do it without writing this step that I'm going to write down first, in which case that's fine. But I'm going to look at my two exponents that I have here of 10, because I have the same bases, right? I have a base of 10 in the first term, and then a base of 10 in the second term, sorry. Now if I look at their exponents, the one exponent is 4y, and the other exponent is 3y. So what I'm going to do is I'm actually going to rewrite 4y as 3y plus y. So I am going to create an exponent with multiple terms. One of those terms being the exponent that my other base of 10 has, right? So I'm breaking up 4y into a 3y plus y, which we didn't have to do in the previous example. In the previous example, we were given exponents with multiple terms. In this example, we are breaking up the 4y into a 3y and a y, so that I can then actually split up that exponent and then take out a common factor afterwards. All right, so I'm going to rewrite this as 3 times 10 to the power of 3y plus y minus 6 times 10 to the power of 3y over 3 times 10 to the power of 3y. All right, I'm almost ready to take out a common factor. I still need to split up this exponent because it has multiple terms now, because I wrote it as 3y plus y so that I would have a common exponent that will allow me to take that out as a common factor. So I'm going to have 3 times 10 to the power of 3y times 10 to the power of y minus 6 times 10 to the power of 3y, and that is all over 3 times 10 to the power of 3y. Now we should be able to see that lovely. We have a 10 to the 3y over here and over there, so we can take those out as a common factor. We don't have to factorize the bottom because that is already one term. So at the top, oh, and actually now that I think of it, we can actually see that we have a 3 and a 6, and 3 and 6 also have a common factor, right? 3 is common in both of those numbers. So let's take out 3 times 10 to the power of 3y. If I look at my first term, if I divide that by the common factor that I've taken out now, I'm going to be left with 10 to the power of y minus, now remember I'm dividing the 6 by 3, which is 2, and 10 to the power of 3y divided by 10 to the power of 3y is just 1. So that whole last term, if I divide it by the common factor, I'll do it on the side quickly. If I have this divided by the common factor of 3 times 10 to the 3y, those are going to cancel out, and 6 divided by 3 is 2. Okay, so that's where that 2 comes from. At the bottom, I still have that same denominator, which now works out so nicely because now I can actually cancel those out. I have one term at the top, one term at the bottom. I can cancel out. I'm now allowed to cancel those out. And my final answer is simply 10 to the power of y minus 2. You could write over 1 if you wanted to, but your final answer you can't leave as that over 1. That's not the simplest form, so this would be your final answer. Right, now grade 10s, in a test or exam, we are not going to split yesterday's questions and today's questions up. They will be given to you in a mixed question. So you need to look at a question and you need to recognize, firstly, so I'm just going to write summary. How do you know which method to use? Because the two methods are very different, right? You're going to have to understand exactly which method you have to use. So if you are multiplying and dividing, these are the ones that we did yesterday. Then you are going to write all bases in terms of their prime factors and then after you've done that, you are going to apply the laws of exponents. All right, you can look at yesterday's examples again if you are confused by what I've just written down. So that is when you are multiplying and dividing. You have to have all your bases the same because the laws of exponents rely on having the same bases. So that is your first step that you're going to do. Write all bases in terms of their prime factors. That's the easiest way of getting them the same. And then you're going to apply the laws of exponents after that in order to actually simplify the whole thing. When you are adding and subtracting, then you are going to break up or split up, let me use that term, split up exponents with multiple terms then you are going to factorize, and then you are going to cancel out and simplify what is left. So kind of the core idea of this method in this type of question that I'm going to underline here is that you need to factorize. So you need to split up your exponents with multiple terms. That's your first step. But the reason why you're doing that is so that you can factorize, which will allow you to cancel out. Grade 10s, it's very important that you understand the difference between these two questions. The one is times and divide, the other one is plus and minus. You need to be able to recognize what type of question it is so that you can then use the correct method. If you mix these two methods up, you will unfortunately end up getting 0 because you can't use the plus and minus method to solve a times and divide question. You can't use a times and divide method to solve a plus and minus question. They are not interchangeable, unfortunately. Now, yesterday I wrote down the questions that you should be able to do. So I'm just going to put these here again. So from the tutorial, you should now be able to do all of these questions that are written here. We are going to be looking at possibly some more difficult ones tomorrow, depending on the feedback that I get from you guys in terms of how it's been going on these 2 days that I have not been at school, or we might start working on exponential equations. All right, so we will discuss that tomorrow in class and decide on a way forward, but try and do as many as possible of these questions today. Even if you're not done with section A and B yet, I want to urge you guys to work on section D, because these are, sorry, let me just do that. These are now the two different types of questions that you need to be able to identify the type and therefore choose the correct method. So please try and do, I want to say, at least 3 of each of these questions in these exercises today, so that you have a handle on things before we move on to the next section. All right, thank you, grade 10s. Enjoy the rest of your day.